Imagine a time before time existed, a time so distant and so alien to our understanding that it defies the very concepts we use to make sense of our world. A time before space stretched out in all directions, before the vast expanses of the cosmos came into being. This was a time when everything we know and everything we are was compressed into a single, infinitesimally small point. This was the singularity, an infinitely dense and hot point containing all the energy and potential of our universe. Imagine all the stars, planets, galaxies, and even the empty space between them, all packed into a point smaller than an atom. We can't fully comprehend the conditions of the singularity, a realm where the laws of physics as we know them break down. In this extreme environment, our current understanding of space, time, and matter ceases to apply. But from this incomprehensible point, our universe sprang forth. In a moment of unimaginable transformation, the singularity began to expand, setting the stage for everything that would follow. Around 13.8 billion years ago, something incredible happened. This event, known as the Big Bang, marked the birth of our universe. It was not just the beginning of matter and energy, but the very fabric of space and time itself. The singularity began to expand rapidly in an event we call the Big Bang. This was not an explosion in the traditional sense, but rather an expansion of space itself, carrying all the energy and potential of the universe outward. It wasn't an explosion in the traditional sense, with matter bursting into a pre-existing space. Instead, it was the expansion of space itself, a stretching of the very fabric of the cosmos, creating space as it expanded. Instead, it was the expansion of space itself, carrying all the energy and potential of the universe outward. This expansion was incredibly rapid, a process that we can only begin to understand through the lens of modern physics. This expansion continues to this day, shaping the cosmos as we know it. Galaxies move away from each other, stars are born and die, and the universe continues to evolve in ways both subtle and profound. The Big Bang marked the beginning of time and space as we understand them. It was the starting point of a journey that has led to the formation of galaxies, stars, planets, and ultimately, life itself. It also marked the beginning of a cosmic journey, a story of expansion, cooling, and the formation of everything we see around us. From the hot, dense state of the early universe, matter began to coalesce, forming the first atoms, then stars, and eventually galaxies. From this single point of unimaginable density, our vast and complex universe emerged. Over billions of years, the universe has continued to expand and evolve, giving rise to the rich tapestry of cosmic structures we observe today. It's a story that continues to unfold today, a cosmic narrative written in the language of stars, galaxies, and the very fabric of space-time itself. As we look up at the night sky, we are witnessing the ongoing story of the universe, a tale that began with a tiny point called singularity and continues to evolve with each passing moment. The singularity is not just a concept of the past, it is a reminder of the incredible forces and events that have shaped our existence. It challenges us to think beyond the limits of our everyday experiences and to explore the profound mysteries of the cosmos. Even today, we can detect the faint echoes of the Big Bang in the form of cosmic background radiation, a relic of that primordial explosion that still permeates the universe. This radiation provides us with a glimpse into the conditions of the early universe and helps us understand the processes that have shaped its evolution. Scientists around the world continue to study the universe, using advanced telescopes and observatories to peer deeper into space and further back in time. Their discoveries not only expand our knowledge of the cosmos, but also inspire us to ask new questions about our place in the universe. As we continue to explore the universe, we are also looking ahead to its future. The story of the cosmos is far from over, and the singularity that marked its beginning is just one chapter in an ongoing saga of cosmic evolution. So, the next time you gaze up at the night sky, remember that you are looking at a universe that began from a tiny point called singularity. It's a humbling and awe-inspiring thought, reminding us of the incredible journey that has led to the world we know today. In the first fleeting fractions of a second after the Big Bang, something remarkable occurred: inflation. This wasn't just any ordinary expansion, it was an exponential growth spurt that defies our everyday understanding of speed and scale. Imagine the universe, in its infancy, suddenly ballooning outwards at an unimaginable rate. This period of exponential expansion, faster than the speed of light, smoothed out the universe's initial irregularities, creating a more uniform distribution of energy and matter. Before inflation, the universe was a chaotic mix of high-energy particles and radiation, with no clear structure or order. But as inflation took hold, it stretched and flattened these irregularities, setting the stage for the cosmos we know today. Imagine a balloon with wrinkles on its surface suddenly inflating to an enormous size. As the balloon expands, those wrinkles smooth out, leaving a more uniform and even surface. This analogy helps us visualize how inflation worked on a cosmic scale. The wrinkles would smooth out, creating a more uniform surface. In the same way, the rapid expansion of the universe during inflation smoothed out the initial chaotic conditions, leading to a more homogeneous and isotropic universe. This is similar to what happened during inflation. The universe's rapid growth spurt ironed out the creases and folds in the fabric of space-time, making it more uniform and setting the stage for the formation of galaxies, stars, and planets. This period of rapid expansion stretched out any initial lumps and bumps in the fabric of space-time, laying the foundation for the large-scale structure of the universe we observe today. Without this crucial phase, the universe might have remained a chaotic and inhospitable place, with no chance for the complex structures we see now to form. Without inflation, the early universe would have been a chaotic and uneven place, unlikely to support the formation of stars, galaxies, or even life itself. The initial conditions would have been too turbulent and disordered for gravity to pull matter together into the structures we see today. Instead, thanks to this brief but crucial period of hyperexpansion, the stage was set for a universe filled with structure and wonder. The smooth, uniform conditions created by inflation allowed gravity to work its magic, pulling together clumps of matter to form stars, galaxies, and eventually, the vast cosmic web that fills our universe. This incredible transformation from chaos to order is one of the most fascinating chapters in the story of our cosmos. As the universe expanded and cooled after the rapid inflationary period, the immense energy that filled the cosmos began to transform into matter. This transformation was not instantaneous but a gradual process that unfolded over time, setting the stage for the complex structures we observe today. Initially, this matter wasn't the familiar atoms and molecules that make up the world around us. Instead, it was a swirling, incredibly hot soup of fundamental particles. These particles were in a state of constant motion, colliding and interacting in a chaotic dance that defined the early universe. Among these fundamental particles were quarks, which are the building blocks of protons and neutrons, and leptons, which include electrons. Quarks and leptons are the essential components of matter, and their interactions would eventually lead to the formation of more complex structures. Imagine a cosmic dance floor where particles collided at incredible speeds. This dance was not a gentle waltz, but a frenetic and energetic series of collisions. Each collision was a high-stakes event, governed by the fundamental laws of physics, determining the fate of the particles involved. These weren't the graceful waltzes of our world, but rather energetic collisions, interactions governed by the laws of physics. The particles moved at nearly the speed of light, and their interactions were both violent and transformative, leading to the creation of new particles and the annihilation of others. These high-energy interactions led to the creation of protons and neutrons, the particles that would eventually form the nuclei of atoms. The formation of these nuclei was a critical step in the evolution of the universe, as it allowed for the eventual creation of atoms, and subsequently, the complex matter that makes up stars, planets, and life itself. This era marks a crucial transition in the early universe, from a sea of pure energy to a universe populated by the building blocks of matter. The transformation from energy to matter was a fundamental shift that set the stage for the formation of galaxies, stars, and planets. It's a testament to the interconnectedness of energy and matter, a cosmic dance where one transforms into the other, shaping the destiny of the universe. This dance continues to this day, as energy and matter remain inextricably linked, driving the ongoing evolution of the cosmos. As the universe continued to expand and cool, these fundamental particles began to coalesce into more complex structures. Over billions of years, these structures evolved into the galaxies, stars, and planets that populate the universe today. The journey from a hot, dense state to the vast, intricate cosmos we see now is a story of transformation and evolution, driven by the fundamental forces of nature. The large-scale structure of the universe, with its vast web of interconnected galaxies, is a direct result of these early processes. The interplay of gravity, electromagnetism, and nuclear forces shaped the cosmos, creating the intricate tapestry of matter and energy that we observe today. This grand cosmic narrative, from the first particles to the formation of galaxies, underscores the profound interconnectedness of all things in the universe. For hundreds of thousands of years after the Big Bang, the universe remained a dark and opaque place, filled with a dense fog of hydrogen and helium atoms. But gradually, gravity began to exert its influence, pulling matter together into increasingly dense clumps. These clumps eventually became so dense and hot that nuclear fusion ignited within their cores, releasing an immense amount of energy in the process. This marked the birth of the first stars, colossal furnaces that flooded the universe with light and heat for the first time. These early stars were very different from the ones we see today. They were much larger and short-lived, burning brightly for a few million years before exploding as supernovae.